All right, so today we're going to talk about a different method of reasoning, which I bet you can guess what that method is called. Deductive reasoning. Okay, so we spent most of this chapter so far working on inductive reasoning. Can somebody describe for me what inductive reasoning is? Solving how? Using patterns, right, good. So you're using patterns to solve problems, okay? Good, so that's what inductive reasoning is. And one of the things that we talked about is that it can be dangerous because sometimes patterns that appear to be true eventually break down and are no longer true. So it's a good way to come up with conjectures or educated guesses, but we need a way to prove that those conjectures will always be true. And that method is called deductive reasoning, okay? And so deductive reasoning is what you normally think about doing in a math class, for example, as we pointed out in a algebra class, where you are taking steps to solve a problem, and you know along the way that each step that you do is correct because you can sort of justify it by using some logic, all right? So, for example, if I asked you to solve this equation, what is the first step that you would do, Riley?
Distribute.
Okay, so I would distribute. So I would change this into 6x plus 3 plus, you want to distribute here also?
Yeah, 4x
okay.
plus 2.
Nice. 4x plus 2 plus 7 equals 42 minus 5x. And the way that I know that that is true is from what he said. That is using something called the distributive property. Okay, so the distributive property allows me to go from this step here to this step right here. Okay, what's the next thing that you would do in solving this equation? Jed? Combine like terms. Can you give me an example of some like terms that you would combine, Jed?
6x and 4x.
Okay, 6x's plus 4x makes 10x's. And what else can I do? Riley?
7 plus 2 plus 3.
Okay, good. 7 plus 2 plus 3 makes what? Makes what? 12. Okay.
Wow.
And that still equals 42 minus 5x. And the step that we would use to justify that is, Jed said, combining like terms. All right? Keep going. What do we do now?
Add 5x to both sides.
Add 5x to both sides.
It's a negative 5.
Okay. So she's going to add 5x to both sides over here. 10x's plus 5 more x's is 15x's. Still have the plus 12 equals just 42 now because the 5x is canceled. Does anybody remember what that's called when you do that? Not the reciprocal, not the inverse, but because we are, what's the math operation she did? That's the, I think they call it the additive property of equality. Does that work? But if you add the same thing to both sides, it'll still be equal. Okay, so you can add the same thing to both sides and you'll still have an equal equation. Okay, almost there. What do we do next? Subtract 12 from both sides. So let me put this on the other page. That's going to leave us with 15x equals 30. And what's the property there?
Division
sub-
property of
Subtraction
Same thing.
property. Okay, where if we subtract the same thing from both sides, we still end up with a true statement. And then the last thing we get is divide by 15. So we find out that x equals 2, okay? And we know that that is 100% correct because every step of the way along the process we were able to give a justification for why we got from one step to the other, okay? So do you see that it's a little bit different than looking for patterns and then making guesses, even though they're educated guesses that are usually true? It's listing all your steps and giving the reasons for the steps as you go. And it is a very important skill to learn, because a lot of times as an adult, you are asking somebody else to believe in something that you think should be done. And you don't just go into Mr. Pugh and say, hey, I really think that Riley should be suspended for the next 2 weeks. And he just goes, okay. You say, I think Riley should be suspended for the next 2 weeks, and here's why. He is constantly acting up in my class. I already gave him a referral. It says in the student handbook that this is the results of this thing, and therefore he should be suspended for 2 weeks. And then he says, okay, so Riley, will you please report to the principal's office? No, just kidding. Okay, so you do need to be able to, as an adult, logically reason your way through an argument so that you can, get others to agree with you, or you need to be able to understand the logic that they're trying to use to persuade you that something else is true. Okay, so this is a valuable skill. All right, so we're going to do this, of course, being a geometry class in more of a geometric way. So let's take a look at this fun little problem here. We're going to start with a couple of segments. And in each one of these, a couple different things are true. So let me draw the two different segments. So AB is 25, CD is also 25, and the middle of that one is 75. This one we're going to do basically the same thing but use different numbers. So this is 36, 80, and 36, okay? So we have two different segments here, labeled the same way, but the distances between the points are different. And in each case, the segments on either end are congruent. So AB and CD are both 25 on the first segment. AB and CD are both 36 on the next segment. All right? You with me? Yes? No? Maybe? Yeah? Okay. All right, so from this, what is the length of AC here? From the markings on the diagram. 100. What is the length of AC over here? 116, okay? On the first diagram again, what is the length of BD? Still 100. And over here, what is the length of BD? 116. Okay? So using a little bit of, can you give us that stock piece right now? Okay. Using a little bit of inductive reasoning, what conclusion can you make about this little setup with the segments? What's that?
They're similar.
What is do I want to say similar, or what's true about AC and BD in this case? Oh, okay. What's true about AC and BD in this case over here? They're the same. What's true about AC and BD in this case here? They're the same. Okay. What had to be true in the beginning for that to happen? What's that? What did we know to start with for those two overlapping segments to end up being the same? Yes?
A, B, and CD had to be equal.
Right, A, B, and CD had to be the same. So if I drew another segment like this, and this time I did not put numbers on here, but I said this is A, this is B, this is C, and this is D, and this time I used our geometric markings to show that A, B, and CD are the same. What would you say you could conclude about this drawing? Yes, Colton.
AC
Right, once again, you could say that AC is going to be the same as BD. Does that make sense? So as long as these two segments on the end are the same, then if I add this little piece in the middle to both sides, then those two pieces are going to be the same as well, okay? How could we use some logic instead of just looking at a pattern and saying it looks like it holds true for the first two, so therefore it has to be true forever, to prove using deductive reasoning that this is always going to be the case? Let's start out by writing out a little thing here. I know that AB, what's true about AB and CD to start with? They're congruent, okay, so I'm going to say the length of AB is equal to the length of CD, okay? What can I do to segment AB to get segment AC? Right, good. Add BC onto that. So if I go AB and add BC onto it, that will be equal to CD as long as I add BC onto that as well, right? So CD plus BC. If I add BC to both sides, just like we did when we were solving that algebraic equation, these two things will also be true, correct? Okay? But what does AB plus BC equal? What's a simpler way to write that? AC, right. AB plus BC is the same as AC. And how is the simpler way to write CD plus BC? BD, good. Okay. So have I proved to you that this will always be true? Using some logical steps there? Okay. So inductive reasoning and deductive reasoning are a little bit different. Paige, can I get you to turn around? Okay. But they go hand in hand. Inductive reasoning is a great way to come up with what looks like something that's often true, or a conjecture. But then what we're going to start doing now as a class is we're going to take those conjectures and we're going to use deductive reasoning. We're going to use some more logical arguments to prove that they are always, in fact, true. Okay? And so this thing that we just proved right here actually has a little name that you should probably write down because it comes up later in the class. This is called the overlapping segments conjecture. And it says, if segment AB has points A, B, C, and D on it, and it has to be in that order. And what else was true about our segment? What was special about it? What parts were congruent? Right, AB and BC. And AB is congruent to, sorry, CD I mean. Then, what do we know to be true? What have we now proven to be true every single time? AC is going to be the same as BD. Okay, then AC is congruent to D. All right. So that is a conjecture now that since we proved it, we know it is true, so we can use that in the future when we're making arguments about other things, or we can use it to solve problems, and we'll know that we'll be doing it correctly. All right? Okay, so where is the... All right, so there's a few problems for you to work on that use that.
Only
What's that?
a few.
Just a couple. Just one or two.